viewers. I am Mehak Basrani, currently pursuing Integrated Masters of Technology in Information Technology from International Institute of Professional Studies, DAVV, Indore. This video is a part of my college assignment in System Analysis in Design subject under the guidance of Dr. Shaligram Prajapat. In this video, we are going to dive deep into the topic prototyping. But first, let's see what software development lifecycle is. SDLC refers to the methodology with clearly defined process for creating high quality and low cost software in shortest time possible. It defines complete cycle of development from planning, analysis, design, development, testing, implementation to maintenance. From various SDLC models available, here we are going to discuss about prototype model. Prototyping can be defined as conversion of an intangible idea either related to physical or digital world into a tangible configuration to test its feasibility and validity. Prototyping is a powerful bottom-up alternative or supplement to logical modeling. It is a way to allow users evaluate the proposals and try them out before implementation. Before diving deep into the topic, let's first understand the purpose of prototyping and give answers to questions like why do we need to prototype our model or why prototyping is important in engineering. Prototyping is crucial because it helps in rectification of design flaws and loopholes in the very beginning of the project by the collective feedback of users before the public release. It also helps in estimation of profit margins or loss for the parties involved in the project. All in all, prototyping turns an idea into something materialistic which totally justifies the investment in a particular project. Various examples through which we can understand prototype models are first the paper prototype. Paper prototyping is process of developing ideas and designing user flows with hand-sketched screens that represent a digital product. The primary goal of paper prototyping is to map our information architecture and visualize user flows. Second, 3D print. The 3D printing is a process of making three-dimensional solid objects from digital file which can actually work and make more sense. Let's now dive deep into the process of prototyping. The first is requirement gathering and analysis. A prototype model begins with requirement analysis and the requirements of the system are defined in detail. The user is interviewed in order to know the requirements of the system. Second, the quick design. Quick designs, when requirements are known, a quick design of the system is created. It is not detailed design. It includes the important aspects of the system which gives the idea of the system to the user. Third, build prototype. Information gathering from quick design is modified to form a prototype. It represents a rough design of the required system. Fourth, customer evaluation of prototype. The build-up prototype is presented to the customer for their evaluation. Lastly, prototype refinement. Once the user evaluates the prototype, it is refined according to the requirements. When the user is satisfied to the developed prototype, a final system is developed based on the final prototype, which is developed by the iterative method, means we design the system according to the final prototype. After that implement, test the product to find the error and at last we maintain the system. Now, there are various softwares that can be used for prototyping tools. Let's see some of them. Photoshop. Who has not used Photoshop even once in life? Almost every designer had gone through it in their life at least once. It is extremely versatile software is a web-based designing software app also used for prototyping. InVision is also widely used for prototyping and collaboration among people who work remotely. XU is also one of the most celebrated prototyping tools out there, which generates high quality and user friendly and interactive prototypes. Now let's see what actually is difference between prototyping and conventional approaches. With prototyping process, the idea is to see if a product will be viable. Once it is determined, each subsequent prototype will be used to gain feedback. This process can move very quickly, particularly if you and your teams can provide immediate feedback based on each prototype. Whereas with traditional development, project requirements are clearly defined at the beginning of the process, and frequent changes are not common or expected. This is a rational approach. It assumes that processes can be optimized, problems can be well defined, and results can be well predicted. Software prototyping is used in typical cases, and decisions should be taken very carefully so that efforts spent in building the prototype add considerable value to final software development. The model has its own pros and cons, which discussed as follows. First, let's see some of the pros. It helps to reduce time and cost as the defect can be detected and rectified much earlier than a public release. Since working model of system is displayed, the user gets better understanding of system being developed. It also increases user involvement in the product even before its implementation. Missing functionalities can be identified easily. It can also expose developers to potential future system enhancement. Various cons associated with prototyping are risk of insufficient requirement analysis owing to too much dependency on prototype. Practically, this method may increase complexity of system as scope of system may expand beyond original plans. And also, effort invested in building prototype may be too much if it is not monitored properly. Various key terms used in the presentation are stated here. The first, application generator, a program that starts with the information in graphical, narrative, list, or some other logical form, generates the appropriate source or executable code. Second, fourth generation language, a non-procedural language that generates the appropriate source or executable code from a programmer's definition or description of logical operation. Third, prototype, a preliminary working physical model of a system, a subsystem, or a program. Lastly, prototyping, the act of creating a prototype. References through which I was able to deliver in this video. And that's it. Thank you.